Detection of the spread of COVID-19 in Indonesia using K-means clustering algorithm. By Dr. Engineer Muhammad Yazdi Pusaiden, Bachelor of Computer Science, Master of Engineering. From Department of Informatics, Faculty of Engineering, Tajalako University. Content. 1. Background, problem formulation, problem limitations, research objectives and research benefits. 2. Algorithm and research result. 3. Cluster validation test. Background. Health is a state of well-being ranging from physical, mental and social that allows people to live productive lives. Based on Law of the Republic of Indonesia No. 36 of 2009, health is a human right and an element of welfare that must be realized in accordance with the ideals of the Indonesian nation as intended in Pancasila and the 1945 Constitution of the Republic of Indonesia. The coronavirus or COVID-19 disease began to occur in 2019 until now in 2021. The cause of this infectious disease is the coronavirus. One of the symptoms caused by this viral infection is respiratory problems. This virus spreads or is transmitted very quickly. On March 2, 2020 in Indonesia, 2 positive cases of COVID-19 were first reported. The death rate due to COVID-19 in Indonesia reached 8.9%, the highest in Southeast Asia. The vast territory of Indonesia makes it necessary to group parts based on regions in Indonesia. Based on data contained on the official World Health Organization (WHO) website. https://covid19.hu.int/region/0/country/id/ and the official government website related to COVID-19, namely https://data.covid19.go.id/public/index.html. To date there have been 4,249,758 confirmed COVID-19 cases in Indonesia, and of the total cases there have been 143,608 deaths. Based on these problems, the author decided to conduct research with the title, Detection of the Potential Level of Spread of COVID-19 in Indonesia using the cloud-based K-means clustering algorithm. The data source used as training data comes from the official Kaggle website with the URL address https://www.kagglua.com/hendritino/covid19-Indonesia for 20,816 data. Problem. Based on the description of the background, the problem formulation in this research is how to implement the K-means clustering method for detecting the potential level of spread of COVID-19 in Indonesia using the K-means clustering algorithm. Limitation. 1. The clustering object in this research is COVID-19 data in provinces throughout Indonesia. 2. The research data used is a collection of COVID-19 data in Indonesia from 2020 to 2021. 3. The method used is clustering with the K-means algorithm using the parameter k equals 3. 4. The programming language used is the Python programming language in notebook mode. 5. The attributes that will be used are total case, number of cases, total death, number of deaths, and total recovered, number of recoveries. Objective. Implementation of the K-means algorithm to perform clustering on COVID-19 data to determine the potential for high spread of the virus in regions in Indonesia. The benefit of research. For academic, adding insight into the field of technology in applying the K-means algorithm to detect potential data distribution. For practice, it can be a consideration for transportation passengers to areas with high rates of COVID-19 spread. K-means algorithm. K-means is a portioning clustering method that separates data into different groups. This method was developed by Mac Queen in 1967. This is the data sample of COVID-19 in Indonesia. Compute distance with centroids. 1. Determine the amount of data, p equals 3. 2. Determine the amount k equals 3. 3. Determine the first centroid equals 1, 3, 5, m1 equals 39, 20, 39, m2 equals 2, 0, 0, m3 equals 43, 20, 39. 4. Compute distances with centroid. Pause this video to see the result. The result of compute distances. From the table above, the following regional groups for COVID-19 are obtained. Cluster 1 equals 3, Cluster 2 equals 2, Cluster 3 equals 1. This is the table of cluster. Two-dimensional feature data, confirmed and death. Two-dimensional feature data and frequency. Two-dimensional feature data. Three-dimensional feature data, confirmed, death and recovered. Three-dimensional feature and frequency. Three-dimensional feature data. Cluster validity test. Silhouette index in each cluster that occurs confirmed, died, and recovered. Silhouette score equals 0.93, 0.9342897740145775. And silhouette index in each cluster that occurs confirmed, died, and recovered. Silhouette score equals 0.94, 0.93587440944108. Data analytics is the future, and the future is now. Every mouse click, keyboard button press, swipe or tap is used to shape business decisions. Everything is about data these days. Data is information, and information is power. Roddy, data analyst at JaMCSIIX2023. Thank you.